This is a demonstration on how to create new target PSD and target RMS distribution functions. This can be done by using Microsoft Excel directly or by launching Microsoft Excel from the Statistical Vibration Synthesizer software. Starting with the target PSD, Excel can be launched by using the right mouse key and selecting Edit PSD Library. This launches Excel and opens the current PSD library. This already contains a number of worksheets, each with information on target PSD data. To create a new target PSD, we insert a new worksheet and give it a suitable name. We now need to define the breakpoints for the new PSD. But before doing that, we need to insert titles for each column. This can be done by copying titles from an existing worksheet. We can now enter the frequency breakpoints, done arbitrarily here. Then we enter the corresponding power spectral densities. Here I am using the SI units to define my power spectral density function. If you wish to use a different unit system, you can use the Excel spreadsheet to make the conversion. The SVS system will only upload data from the first two columns of each of the worksheets. We can now either plot the PSD within Excel or save the spreadsheet and return to the Statistical Vibration Synthesizer main screen. The PSD library needs to be updated and the new target PSD selected from the available worksheets. By default, the software plots the target PSD from the first worksheet in the PSD library. We can now see the target PSD that I just created along with the nominal RMS value. Now that the target PSD has been created, we can decide on the RMS levels to be synthesized by constructing a target RMS distribution. As for the target PSD, this is done by using the right mouse key on the RMS distribution graph and selecting Edit RMS Library. As before, Excel will be launched and the current RMS distribution library will be opened. This shows all the RMS distribution data available in the library. A new RMS distribution is created by first inserting a new worksheet and copying the titles from an existing worksheet. Whatever wording or units used in the titles here will appear as titles for the graph in the SVS software. For example, I can replace the title dose with a new label, say relative duration. In this case, the label relative duration will appear on the graphs on the Statistical Vibration Synthesizer software. Now we can define the RMS bins. It is important to note that the values define the center of each bin. For example, if the first bin is centered at 0.5 and we want a bin width of 1, we then need to enter 1.5, 2.5, 3.5, etc. Using whatever information that is available, we can decide what RMS level we will synthesize and for what proportion of a time. We sometimes call this the vibration dose. Here I enter arbitrary values for some of the RMS bins and zeros elsewhere. The doses should add up to 100%. If they fail to do so, the statistical vibration synthesizer software will automatically detect this and make the necessary adjustments. We now rename the worksheet and save the spreadsheet. We then return to the statistical vibration synthesizer main screen and refresh or reopen the current libraries. We then select the newly created RMS distribution. As the RMS dose values I entered did not add up to 100%, we notice that the RMS dose values on the RMS distribution graph, bottom left, have been automatically adjusted in proportion so as to add up to 100%. It is interesting to note that this particular RMS distribution function, which I just made up with arbitrary values, does not produce a PDF that is highly non-Gaussian. This can be seen better by changing the appearance of the PDF to distorted scales and adjusting the scales. The main reason for this is that there is one prevalent RMS level and only a small proportion of values below and above that level. Despite this, the small RMS dose values are sufficient to distort the PDF to produce acceleration values well outside the Gaussian distribution. If this is not what is needed, the RMS distribution can easily be modified by returning to Excel and editing the RMS table. In this case, I will increase the vibration dose at higher RMS levels without worrying whether the RMS dose adds up to 100%. The system will take care of that. Because an existing worksheet has been changed, a new RMS distribution can be uploaded by simply selecting it from the menu. The effect on the PDF can be immediately seen, including a higher kurtosis value. This tool has shown how a non-stationary test schedule can be defined by creating a target PSD and a target RMS distribution. I have shown how simple it is to create and edit functions using the statistical vibration synthesizer software, which has a direct link with Microsoft Excel.